Hello, welcome back. So this video is a little bit different, and particularly you have permission not to type what I type. And to be honest, I'm not going to type that much. And this is because we are not working on developing new syntax today. This is a more of a theoretical video aimed at trying to increase your understanding of how memory works inside of Python. So let's first take a look at this code here. We got x equals 2. Okay, so this creates a variable called x equal to 2. Then we set y equal to x, so now x is equal to 2 and y is equal to 2. And then, okay, so now we're assuming that this works the way we think it does. So now x is equal to 3. We didn't touch y, so y should be equal to 2. So this should print 3, comma 2. Lo and behold, it does exactly what you'd think. Now here's the thing, is that now let's look at this code, and let's try to apply that same reasoning. Okay, so now x is equal to the list containing 2. And then on the next line, y is equal to x, so x is equal to the list containing 2. And y is equal to the list containing 2. So far, so good. And now we change element 0 of x. So x, there's only one element in x, so now x is the list containing 3. And based on what we think is going on, or what I would think is going on at the very least, perhaps you are smarter than me, we should think that y wasn't touched. So this should print list containing 3, and then print the list containing 2. But we're wrong. So I want to think about this. When you took your first intro to programming course, you probably did an exercise similar to this. You traced everything through. We just applied all of that same logic, and we got it wrong. This is something different. This is something different that it's important for you to understand. So let's try to understand what the hell's going on. Okay. So here we have x is equal to 2 and y is equal to 2. And let's take a look at the memory locations of x and y. And what do we observe? 1407259649738. And then it's the same numbers. I'm not going to say them again twice. So when we just picked x and y to be the same value, they were actually automatically stored in the exact same location in memory. Kind of weird. Okay. Now let's try assigning x the value of 3 and checking the location again. Okay, y is in the same location as before, but x is in a different location. Okay, this kind of makes sense because x and y, we saw that with int, it does work the way you'd think, at least in terms of the output. So they can't be in the same location now that they have different values because y is still equal to 3. Heck, let's just even print this out. Let's print x comma y. And we're going to see that we're going to 3, 2 again. Okay. And now let's try this again. Let's try x equal to 2, y equal to 2, print at x and at y, print x equal to 3, print at x and y. So we're kind of just re-seeing what we saw, which is initially they're in the same location, but then when you change the value of x, x moves. So here's how it works with int and with other immutable types, types that cannot be changed. When you type x equals 2, it creates an instance of the object 2 inside of the memory, and it binds the name x to the object 2. Now when you type y is equal to 2, it observes there's already an object called 2, so it binds the name y to that same object. When you type x equal to 3, the computer wants to change the object bound to 3, but it can't because ints are immutable. So therefore, it creates a new object called 3, unbinds the name x from 2 and binds it to 3, but y is still bound to 2. Okay, now let's look at how memory works with lists. So we got x equal to 2, y is equal to x, and let's go ahead and print the location of x. And we're going to set x of 0 equal to 3, and then print the memory location again. So with lists, when you say y is equal to x, This means that the name y and the name x are going to be bound to the same object, which is the list containing 2, and therefore they're in the same memory location. When you type x of 0 equals 3, it tries to change that object, and that object is the same for both x and for y. And lists are mutable, so it's perfectly well able to change the name of the list. So it changes that one object, and the name x and y are both bound to the same objects. So here's how it works with lists. Excuse that letter L there. Let's get rid of that. Okay. So when you type x equals 2, it creates a list containing the number 2 and binds the name x to that list. When you type y equals x, it also binds the name y to that same list. When you type x equal to 3, the computer can change the name of the object bound to the name x to be the objects of the list containing 3, because lists are mutable objects. Sorry, this should say mutable. There we go. Therefore, x and y are both still bound to the original list. There's a different value, but it's still the same object in the computer's memory, and the letters x and y are both refer to both of them. Okay, so now let's try one more example. Let's try typing x is equal to 2, y is equal to the list containing 2, x is equal to 3, and let's print x and y. Alrighty, and here we can actually check if we just do a printout of the id of x and the id of y, that they were actually never assigned to the same object. This whole thing where the computer sees that an object exists and it automatically binds y to the same object as x, that applies to immutable objects. It does not do this by default if you're working with a mutable object, unless you type in y is equal to x. And once again, we see that despite having the same value, x and y never have the same memory. And we can contrast that with this, where we see we got 973,888, 973,888. That's how it works with immutable objects. And so, in summary, if A is immutable and B is assigned to the same value as A, Python automatically binds the name B to the same fundamental object inside the computer's memory as A. However, if it's a mutable object, like a list, it does not do this unless you type y is equal to x. So it's very important to be cognizant of this, because not thinking about this is a great way to make a really confusing error, which will take you many hours to debug, and then you will gradually remember that this is how it works, and then you will be very mad at yourself. So thank you for bearing with me. This lecture was a little bit different, but hopefully this increases your guys' understanding of how memory works in Python. Thank you.